Okay, so last time we learned lots of things lah, especially actually last time kita start dekat 6.3. 6.3 tu bila kita stop, kita tak cover satu lagi part, which is about resonant. So today we learn about resonant. But before that, I just want to ask you guys, yang the first one ni symbol dah ingat lagi tak? This one. This one is for what?
Resistor.
And this one is resistor. Yang the second one tu RC. Number dia adalah
Capacitance.
capacitive reactance. Okay. And the last one tu adalah capacitive as well. And then the last one is inductive reactance. Okay. Each one of these adalah resistance. Setiap satunya adalah resistance. Okay. And then obviously kita ada belajar lagi satu, which is about Z. Okay. We call Z as impedance. Okay. So kalau Z ni, kamu tahu formula dia, Z is equals to square root of R square plus XL minus XC square. Okay. But then for XC and XL, actually you have a formula as well. So basically you can calculate some XC and XL. So XC you can calculate using equation of 1 over omega C, which is equal to 2 pi FC. Okay. But for XL, this one is 2 pi FL. Okay. C here is the capacitance that has a unit of farad. Okay. L here is the inductance. Unit dia adalah Henry. Okay. So you can see that over here, the resistor is basically a constant value. Okay. So as long as you have a constant temperature, the value for resistor is a constant. Okay. On the other hand, over here, you can see that XC actually depends on the frequency. Okay. Capacitance is constant, but the frequency can change. Okay. It really depends on the frequency. So if the supply frequency is high, then the value also of F is really high lah. Kalau F dia kecil, then this one is value of X ni akan jadi besar lah, the inverse proportional. So the relation here, you can say that XC is inversely proportional to the frequency. Okay. And XL here is directly proportional with the frequency. Okay, so far yang ini yang penting lah dan saya nak tunjukkan for today lesson. Okay, any questions so far?
No, sir.
Okay, so remember, because XC and XL, you have a specific formula, like this one and this one. So XC is inversely proportional to the frequency. XL is directly proportional to the frequency. Okay, kalau dia directly proportional, graf dia macam mana? Kalau saya nak bikin graf, ni lah. Kamu rasa lah. Adakah dia curve? Adakah dia straight line? Ataupun dia flat? Which one?
Straight line.
It's a straight line kan? Dia akan menaik dengan direct proportional. Okay, let's see if I want to draw Z against frequency, which is order resistance. So Z ni include Z, XL, XC dengan R lah. Okay, so kalau saya nak plot yang XL tadi, macam kamu cakap, dia adalah direct proportional, so dia adalah straight line like that. Okay, this one is your XL. And then for XC, dia adalah 1 over F. This one. Okay, so kalau 1 over F, dia actually adalah curve. So it looks something like this. Okay, so this one is for your XC. Okay, the resistor, does it change with the frequency? Berubah tak dengan frequency resistor? Sekejap saya. Constant maksudnya berubah ke tidak?
Tak.
Tak, kan? So kalau dia tak berubah, maksudnya kalau dalam bentuk graph, dia akan jadi a straight line. Okay? So basically, you have a graph that looks like this, a flat line. Okay? This is your R. Okay, so XL, kamu dapat macam tu sebab XL is directly proportional with the frequency. R is a constant, that's why you have a straight line. XC is inversely proportional, that's why you have a curve like that. Okay, the Z will look something like this. Okay, and this one, if you really want to get this kind of shape, basically you have the data, and then when you plot the data, you get this kind of shape. The shape dia macam U, tapi dia macam skew sikit ke to the right tu. Okay, and then if you notice, you have 2 points over there. Okay, so over here, if I draw a line, okay, dekat sini is what we call the resonant frequency. Dekat these 2 points is what we call the resonant frequency. The unit for resonant frequency is hertz. Okay, kalau saya cakap pasal resonant, apa yang pertama sekali kamu terfikir?
Kalau resonance apa sah?
Apa yang kamu terfikir bila kalau saya sebut pasal resonance? What is the first thing yang kamu terfikir?
Wave.
Wave, okay, very good. Okay, back to this one. Dekat frequency resonance tu ada 2 point ni. So over here, yang ini adalah kamu punya Z. Yang purple tu is your Z. So you can say that dekat point yang atas tu, Z is equals to R. Okay. Maksudnya, masa dekat resonant frequency, value untuk impedance sama dengan value untuk R. Kalau untuk more specific, this one adalah Z minimum. Okay, so this is your Z. So the minimum value is over here, and this one is equal R. Exactly when the resonant frequency. Okay, and then lagi satu point bawah ni, you can see that green dengan blue ni overlaps. Okay, yang green tu adalah your XC and the blue is your XL. It means that your XC is equals to XL. Again, masih dekat resonant frequency. Okay, and then if you guys still remember, kalau kamu bikin phasor diagram, mana saya nak tahu phasor diagram? Okay, let's see if I draw the phasor diagram over here. Okay, let's say this is your XL, this is your XC, this is your R, and that one is your Z. This is your phi. So your cos phi actually is equals to adjacent over hypotenuse. So that means this one is R over Z. Okay. So at this particular point, R is equals to Z. So cos phi dia jadi apa?
Macam mana sah? Tak faham.
Kalau cos phi R over Z, and then R tu nilai dia sama dengan Z, so cos phi tu jadi apa? Kan cos phi tu sama dengan R over Z. So kalau R sama dengan Z, maksudnya yang ni jadi apa? 5/5 contohnya, dia jadi apa?
1.
1. Okay. So dekat resonant frequency, cos phi dia adalah equals to 1. Okay. Cos phi ni kita akan belajar sekejap lagi dekat satu topik seterusnya. Cos phi ni represent power factor. Okay. Power factor ni indicates the efficiency of a electrical appliance. Means that kalau dia punya power factor adalah 1, dia dekat maximum efficiency. Dia paling efficient lah. Maksudnya power yang diberi sama dengan power yang dapat. Okay. Nanti kita akan discuss further about this power factor. Okay. Tapi remember, at resonant frequency, dia ada 3 main important things. Number 1, Z min is equals to R, XC is equals to XL, and then cos phi is equals to 1. Okay, moving on to the next one, we want to discuss about power and power factor. This is the last subtopic 6.4. Where's the unit for power? Ingat lagi tak? Unit power apa?
Watt.
Watt. Okay, good, very good. So watt symbol dia adalah W. Okay. And then power factor ni, remember, power factor is actually cos phi. Dia bukannya phi, dia adalah cos phi. Okay. Before we go into power factor, we want to focus about power first. Power ni biasanya ada few power yang ada lah. Kalau kamu tengok, kamu akan jumpa dalam chapter ni ada power average, power instantaneous, peak power, apparent power, and real power. Okay. But then over here, we start with the instantaneous power first. Okay. Instantaneous power means that power at one particular time. So maksudnya bila time is equals to 3 second, power dia berapa? Itu soalan dia. Okay. At specific time. Okay. So from previous chapter 3, we know that P is equals to IV. Okay. But remember that this one is I and V with respect to time. Okay. So I tu kalau 5 saat berapa? V tu kalau 5 saat berapa? Itu maksud dia. Just want to write in terms of T. Okay. So you multiply those value. Contohnya kamu dah kira current bila 5 saat 5, voltage bila 5 saat adalah 3, dan power equals to 15. Itu maksud dia lah. Right? And then show you dia ada derivation, dia ada sebab dia. Kalau dekat kapasitor dengan induktor, basically there will be no power loss. Sebab bila kamu kira average power dia dekat induktor dengan kapasitor, dia adalah 0. They cancel out each other. So dua tu adalah tak ada power loss. So the only power occurs dekat dalam resistor. Ingat ni. So I'm not going to show the derivation. Kamu just tahu yang resistor saja yang boleh produce power ataupun ada power loss. Okay, so dekat across the resistor, if you guys still remember, kamu punya phasor diagram is basically VR to the right ataupun R to the right, and then kamu punya current also to the right. Okay, so it means that I dengan VR ni dia bergerak together. So dia punya formula adalah sin omega T. Kalau dia punya graph pun memang graph sin lah. So basically it depends on the situation. Kamu cari I dengan V dulu, masuk je dalam ni. Okay. Kalau saya masukkan these two, basically I will get like this lah. Ini saya sikit satu part kot, saya buat turun this one. Okay, P tadi sama dengan I darab V kan. So P here is equals to I, which is I naught sin omega T. Okay, multiplied by V naught sin omega T. If you multiply these two, your I naught multiply V naught, kamu bawa depan. Your sin here becomes sin square. Okay, dalam dia tak berubah lah. So jadi I naught V naught sin square omega T. Okay, this one I can represent in terms of graph. So in this one, dia adalah asalnya dia adalah I naught V naught. Okay, if I want to plot sin square, basically it is just a sin graph. Cuma dia dekat belah positif. Okay, So kalau sign yang biasa dia macam ni, sign yang ini dia macam ni. Okay, semua dekat atas belah positif. So just, so saya dah lukis tadi. Oops. I'm going to place it over here. Okay, so you can see that power ni, dia punya motion dia still sinusoidal. So ada sine. Okay, and then you still have the period and all lah. So this one will be your, kalau from here to here, this will be one period. Sini to sini. Okay, kalau yang this one will be one period. Okay, anyway, the maximum over here is what we call P0. Okay, P0 here is your maximum power. And so basically, the P0 is your amplitude, and the amplitude is this one. So P is equals to P0 sine square omega T. So your P0 is actually I0 V0. We go back over here, it's equals to I0 V0. And over here, if you want to calculate the P average, basically I just take half of this. Okay. So half of this graph is basically your P average. So this one will be your P not over 2, which is equal to P average. So I can write it down as half I naught V naught. Okay. Average power. Symbol that we use kalau kamu perasan saya pakai AV E. Ada book dia pakai AV je. Sama je lah. So yang not ni untuk maximum power, yang AVE ni adalah average power. So I just want to write over here. P average, symbol dia AVE. Average power. Okay, dia punya unit still watt. Okay. Dan dia ada specific formula. P average equals to I RMS, V RMS plus V. So selain daripada yang half I naught V naught tu, we can write in terms of I RMS, V RMS, but make sure you write down in terms of cos phi. Cos phi tu kena ada. Okay. Dia yang sebenarnya, sebab power loss ni only occurs dekat resistor. So your P average masih lagi IV, tapi kamu kena pakai VR. Okay. Sebab apa nak pakai VR? Sebab dia nak voltage across the resistor. And then if I substitute VR ni with Ohm's law, V sama dengan IR, then I will get I squared R. Okay. So most of the time, I would like my student to use P average equals to I squared RMS R punya formula. Okay. Because this formula, you don't have to use cos phi. Sebab cos phi selalu student terlupa. But if you want to use this formula, tak ada masalah pun. Cos phi tu sebenarnya adalah, kalau ni phasor diagram, in terms of voltage, this would be your VL, VC, VR, and VRMS. This would be your phi. Okay, so your cos phi here is actually equals to adjacent over hypotenuse, which is VR over VRMS. Okay, so if I rearrange VR2, I will get VRMS cos phi. So if I substitute this one inside here, then basically I will get this one. Okay. So yang asalnya is this one. Tapi sebab VR tu, kalau dalam soalan jarang diberi. Okay, nilai VR tu. So most likely you can straight away use this formula to calculate ataupun this formula. But remember, if you use RMS, VRMS, you must include cos phi. Okay. Okay, now about power factor. Okay, power factor is basically cos phi. Yeah, power factor is cos phi. Dia bukan phi, dia adalah cos phi. Okay. Kalau kita assume that cos phi is equal to R over Z, okay, sebab apa? Dia datang pada phasor diagram kan? Resistor over Z. Now you can see that resistor in ohm, Z in ohm. So basically, untuk power factor, there's no unit. Okay, power factor is basically a ratio. So this one no unit And then, in terms of, kan saya pernah cakap tadi dia adalah indicator untuk efficiency of a electrical appliance. This one is equals to PR over PA. PR here represent P real atau real power. PA is apparent power. Okay. So apparent power ni macam tak adalah olok-olok Dia macam kamu beri power tu. Contohnya you give 10 watt. Okay. And then the actual power that you get maybe adalah 6. So less daripada apparent power. So the punya ratio will be 6 over 10. Kalau contoh tadi lah. So this one, still remember that this one is equals to R over Z. Okay. P apparent ni, dia punya formula is R RMS, V RMS. Okay. Kalau yang P real ni, formula dia adalah I RMS, V RMS, cos phi. Okay. So basically, kalau kamu potong ni dengan ni, dia tinggal cos phi lah, so kita dapat yang ni. And then just pusing je. Okay. So basically P real tu adalah P average dia lah yang sebenarnya. Manakala kalau yang P apparent tu dia yang bukan yang sebenarnya. Yang diberilah tapi bukan yang dibiasai. Okay, so ni contoh dia. Power factor So power factor over here is cos phi Cos phi is equals to, kalau kamu tengok dekat ni kan, adjacent over hypotenuse will be true power divided by total power. So ni perumpamaan ni ibarat buih ni. Okay, kamu ada buih, so buih ni obviously buat penuhkan gelas tapi dia tak rasa pun. Yang actual one is yang bawah ni. Okay. So we call this one as real power lah. So here you can see that kalau cos phi dia adalah yang KW ni, yang water ni divided by total power divided by semua ni. Okay. So yang ini adalah wasted. Yang ini yang diguna. Okay, air ni yang kamu minum. Okay, kamu yang minum lah. Any question so far?
No, sir.
Okay, I think actually we finished the chapter 6. Okay, saya simpulkan sedikit about your power and all. So saya repeat, sebab power ni ada few formulas and student might get confused. Ingat dalam exam biasanya power ni maybe ada dalam dua. Okay, so average power, saya ulang balik P average is equals to I RMS, V RMS. Okay, tapi kamu kena letak cos phi. Okay, remember that. Okay, sebab dia sebenarnya adalah I RMS VR. So VR tu sama dengan V RMS cos phi lah. Okay, alternatively, you can use I squared R. Itu yang saya galakkan. Kalau kamu pakai I squared R, you don't have to bother with the voltage, you don't have to bother with the cos phi. Okay. And And then yang ini, power ni semua hanya berlaku dekat resistor. Kalau instantaneous dekat resistor, sorry. Kalau instantaneous, this one hanyalah IV. Tapi remember, you have to find I with respect to the time works at that particular time. And then you can multiply, and you can calculate. Okay. And the last part yang kita belajar adalah buat power factor. Power factor is your cos phi. Dia adalah real power divided by apparent power. Okay. So, yang P average yang kamu kira tadi tu, dia sebenarnya adalah the real power lah. P apparent dia adalah I RMS, V RMS. So, this one is equals to P average over also remember that this one is equals to R over Z cos phi based on the phasor diagram. Okay, kalau tak ada soalan, maybe you can stop first.